So it's time to add our, I guess, so-called villain here, I guess depending on how you view whether the shark is the villain eating fish or not, but it's the submarine class. So again, my image is facing 0 degrees to help me line things with Greenfoot. And the behavior that I want to program is that the sub is going to be dropping torpedoes into this game. And that's the first thing we're going to do is put a method that does that. So it just drops them. It doesn't really return anything to us about what it did. It's just going to be a void method. So the way you drop this torpedo is you basically create a new one. It's going to place it in the world for us, and the torpedo knows how to act once it's in the world. So that means I need to get the world from the actor. So I place it in the same place as the sub. And to put it in the world, I also need to know where I'm going to be putting it. So the x-coordinate can be the same as the subs, and that'll be right dead center of the sub. So it'll look like it's dropping it out of the middle of the sub. But the y-coordinate is a little trickier, because if I use the center of the sub, then it's going to destroy the submarine. It's basically blowing itself up. So I have to make sure it has enough clearance. And the way I can do that is to get past the image itself. So I get the height of it, and if I divide it by 2, half of it is represented by the y-coordinate. This will push it past the rest of the image. However, that's at the center of the torpedo, so some of that is going to then overlap the sub from above. So what I have to do is add the torpedo's height as well. So torpedo.getImage, get height, and I need half of it. And of course there could be some rounding issues here because I'm doing integer division, so I'm going to put a bit of a buffer there just to make sure it did get past it. So now I can say world.addObject, and I'm adding the torpedo at that x and y location. So if in my acting code here I drop the torpedo, the only problem here is that, drop torpedo. The only problem here is that when I actually do it, you're going to see that the sub is actually dropping too many. So I'll speed it up just so you can see. So it's blocked, and I don't want that behavior. So we have to figure out a way of slowing down the sub. So what I'm going to do is create another method that'll control whether or not it can fire. And there's lots of different ways you can control it. Our solution here is just going to be to do it randomly. So I'm going to do a random probability of 1 in 100. So the way you set that up is you can just use the math.random class, and I'll do values from 1 to 100. So if it was the case that it's probability 1%, I can think about what value that is, and that would be that it's going to be a 1 or less. Well, basically the only option is 1 out of 100. So if 1 in is less than or equal to 1, and yes, I know it's only going to be equal to a 1 the way we've set up the random number, but if this is true, that only happens 1 in 100 times with those random numbers. So in general, if you want to use this kind of random behavior, this would be 1 in 25. You know, if I wanted to do, say, like 5 out of 27, that would be the numbers 1, 2, 3, 4, 5, the first 5 out of the 27 possibilities. So you can play around with the probabilities in your game, but for now, let's just hope that this is you know, sufficient for producing a nice enemy here. So if you can fire, then drop a torpedo. And again, the reason I'm separating these things out is I don't want the act method thinking about too many things, because then if I want to change the behavior, it's this method that deals with all of the behavior of whether or not I can fire. It doesn't affect the act method. The act method is, once it's coded, it just keeps on doing what it does, and I can update things in can fire without having to worry about what's happening in the act method. So I'll just show you now what the behavior looks like. Here's my sub, and oops, better slow this down a bit. But basically you're seeing it's not always firing, so giving us a bit better chance. And again, we can always try and change that if it's something that we want to slow down or speed up. But you know, for our first game, that's not bad. So the next thing we need to be able to do is turn this sub, and I'll show you the problem that comes up if we're not careful. So if all I did was turn, I could call the parent class and say, hey, flip me 180 degrees. And this is what's going to happen if I use that method. If I turn, it's actually upside down. Now it's not that Greenfoot has a bug in it. The problem is it's facing 0, and we just made it rotate to 180 degrees. So it's actually turning the sub. So by turning it 180 degrees, it's now upside down. There is an easy fix for it, but I just wanted to show you that you have to be careful of that behavior. And the fix for it is to get the image that you used. So Greenfoot image is get image. So that's getting the submarine picture. And there's a method to flip this vertically, and it's called, I'll just show it to you here in the documentation. It's called mirror vertically. So Greenfoot image class, and here it says these are the ones to mirror your image as your games maybe call for it. So I'm going to mirror vertically here so the top becomes the bottom and vice versa. So image.mirror vertically, and then I have to put the image back in. So I'll tell the actor now to set your image to be the one I just flipped. So bring it up in Greenfoot and just show you that this behavior is one I wanted. So if I turn now it's facing the right way, and I can test it and make sure that when I turn back, everything's happening the way it's supposed to. Okay, so now I just need to define the movement for how the sub's going to move. And to do that, we're going to try and make, it's not the smartest sub, but it's going to go and find where the shark is, and then it's going to try and move towards it. So that's the next thing that I want to do, is turn towards the shark. So in the world class, bring it up for you so you can see the documentation. In the world class, there's a method called getObjects, and it's going to get all the objects in the world. And you can tell it what kind of class you want. You can also use null to get every single thing in the world. But the kind of objects we want are sharks. So that's what we're going to do here. Now the list class belongs in the utilities package, so in the import here you're going to have to import java.utilities.list. That way Java will know what it is that you're talking about when you ask for a list. Oops, and of course I need to get it from the world, so world.getObjects will return all the sharks to me. Now the way that you traverse a list is with a list iterator. And that helps get you the things in there, because there'll be more than, well, sometimes there's more than one thing. In our case, there's just the one, but we want a list iterator. And that allows us to get through each place. And until we get to loops, we're not going to really use that functionality, but we're just going to get the first one. So in here, I'm going to ask sharks for an iterator, one that goes through all of these sharks that have been returned. And I guess I'll show you the Java doc here. This is the list class, and the one that I want here is just this iterator method. That way I'm able to, I guess I can also use a list iterator. That's probably more specific, so why don't we do that instead? And what I've now got is access to the objects in that list. So what I'll do is then I'll get the shark. So shark, so this is the enemy, and I'm going to get that one. So again, when you're learning to use these, it's always good to look through the Java documentation and see what you have. But I'm going to be looking for the next element in the set. So I know there's a shark in there. There's some tidiness that we'd want to do generally, which is, to check that there's a next element and then get it. But at this point, the shark is in the game, so for now we'll just call it like it is, and we'll get the next one. Okay, so here, if we compile it, you see it's going to give me this problem that it doesn't know what it is. And what it's saying here is a list can hold any kind of thing in it, and you have to tell Java what you have. So it's just getting an object. Java doesn't know that it's a shark. So one way around this is to cast it. Then Java will say, okay, no problem, now I know you've got a shark. The other way you can do it is you can actually make an element type. So if you don't want to keep casting through your code, you can tell it that this is a list of type shark. And any kind of container in Java usually does this, where you use this kind of notation to say what objects are in your container. So now I don't need to cast it because Java knows they're sharks. So you see, now I compiled with no errors even though I didn't have to do that. So that's my preferred way of dealing with it, so I don't have to remember to cast everywhere that I use my list. There are times, however, when you don't want to make it hard-coded to a shark because you may have more than one thing in there. For example, if I called on, I want all the actors, now that list might actually have sharks, fish, all kinds of other things in it. So again, depending on your application, it may make sense to declare to Java exactly what's in there, or to cast it at the runtime, like the other example here, where we would just say, oh, this is a shark. Okay, so now I've got that enemy, and what I want to do is get its x coordinate. So I'll say enemy x is going to be enemy.getX. And I'm going to use the same y coordinate for the sub. And then I'll just call the parent method turn towards the enemy's x and y. Now the only problem with doing the parent method is the parent method does not know that the sub only turns this way. So we could redefine it, or we could handle it in this part of the code here. And that's what I'm going to choose to do. So if, oops, no thanks, my enemy is to my right, I want to make sure that I'm facing to the right. So I should get my x coordinate as well. So if the x is less than the enemy's x, what that means then is the enemy is to my right. Now, what I want to make sure is that I'm then facing the 90 degree, sorry, that would be 0 degrees. So we'll get the angle here. Maybe I'll just separate this code a little bit. So here I'm going to say if angle is not 0 degrees, maybe I'll say if it's equal to 180, it's facing left. So what we have to do here is turn it. And then that way I know I'm facing the way that my enemy is. Now facing right. Okay. Otherwise, I'll say if my x is greater than the enemy's x, that means the enemy is to my left. So again, I'll check if the angle is 0 degrees, I'm facing to the right. So I need to turn. And that means I'm now facing left. Same way towards my enemy. Otherwise, I'm not going to do anything. If the shark's directly underneath me, then I don't need to actually change my position. So now I can make the movement happen. I can say turn towards the shark in my acting, and then I'm going to say move, and I can call the parent's move class. So I could make it move 1. Why don't we just make it some random amount here, distance equals, let's go between 1 and 5 just to let the sub move a little quicker if it wants to. So then I'll move that distance. Okay, so now we'll put my sub in and we'll let it run to see what my behavior looks like. Oops. Ah, of course. I need a shark there, otherwise it can't do its job. So it's moving towards the shark, and now it's chasing me. Get away. But I can already tell that I don't like that behavior. It seems to be spinning around too much when it's right underneath me. And the error is because the torpedo hit the shark, and now there's no shark in there. So why don't we fix that first, just to make the code a little better. So in here, all I'm going to say is if iter dot has next, if there is a shark in there, then I can continue. And one thing about a void method is you can say there's nothing left to do by just saying return. And that'll happen if there is no next method. So if the iterator does not have a shark, just return. There's nothing to do. It won't. That means it will stop here, and this code won't be executed because there's no shark in the world. So now when I go in, I can run it all I want, and I'm still moving. So let me just find out what's wrong here. Ah, that's why. Because I ended up moving. I end up programming it to move that random amount regardless of where the shark is. And that's what's making it flip-flop when we saw it earlier. So why don't we make a method here that tells us whether we change direction or not. So I think what I'll do maybe is I'll call this move towards shark. And that way I know in here, this method will handle it for me. I'll get the distance, and I only need to move if I've actually made a turn. Because I don't need to move if I'm directly under the shark. If I'm directly underneath it, it's just going to stay still. So there's no need to turn or move. And now I think that behavior should be more realistic of what I want. So if I'm running it, nothing's happening because there's no shark. If I add a shark to the world, however, oops, doesn't look like I'm moving. Let me just make sure. Let me reset the world here. I'll put a sub in, and I'll put a shark in. And I'm not chasing my shark, so just give me 1 second here. Okay, so I reset the world here. I did find my logic error. It was because before I had move up here, so the only way it was going to move is if I had to flip the sub. And that's incorrect. It should have moved regardless because the enemy is to my right or to my left. So because it's on one of the sides, I still have to move towards it. All this was doing was making sure I was facing the direction before I moved. So now that's handled the sub, and it should be working now. So I'll just show you here. If I take my sub, I can run it, there's no errors, and if I add the shark, then it's going to chase the shark down, and if I move, it's going to try and chase that as well. And here's the torpedo, hits the shark, shark's gone. Okay, so that'll do it for what I want for the submarine class.